Hi, my name is Aubrey Wymark. Today I'm going to introduce Tektites. I'm going to look at Indochinites, Philippinites and Australites primarily. Firstly, to introduce Tektites, there are four big strewn fields. The North American strewn field, the Ivory Coast strewn field, the Australasian strewn field, and the Central European strewn field with Moldavites. I'm primarily focusing on the Australasian strewn field. I'm based here in Manila and I have a large collection of Philippinite tektites, also Australites, Bilitinites and Indochinites. Firstly, let's have a look at what we got here. I've got one Moldavite here. They're very attractive, nice green coloration to these ones, a nice surface sculpture. Well, we're not really going to talk about them today, but we will touch upon them because basically all tektites are formed in a very similar manner. Right, so let's look at the Australasian strewn field. The Australasian strewn field is the youngest of all the strewn fields. It's 780,000 years old, which may seem like a long time, but geologically it is actually very recent. There were humans, Homo erectus, living in Asia at the time and likely killed by the impact. The impact occurred in the Indo-Chinese region. The crater it left behind was probably about 40 kilometers in diameter, but has yet to be found. I think the most likely place for that is in the sea, probably shallow shelfal sea of the Bay of Tonkin. And I think that it probably has been seen on geophysical data, but nobody knows about it. It would be interesting in the coming years if anything is discovered or confirmed. It's a big structure, it surely can't be missed. So, okay, when the impact happens, tektites form very early on in the earliest stages of impact. Basically, the asteroid or comet is travelling at very high velocity. When it impacts the ground, a lot of its kinetic energy is converted to heat. This basically melts the terrestrial rock. In order to form tektites, the terrestrial rock, it has to be of the correct composition, so high in silica. This is why we don't find tektites on the moon really, because there isn't much silicious rock. But on Earth there is a lot of silicious rock. Sedimentary rocks such as sandstone or shale are ideal for making tektites. So basically the kinetic energy converts to heat and ejects this molten terrestrial rock up into subspace, and it rains down at different distances. Forms that land at different distances have very different characteristics, and we'll come to that and explain why later on. When the asteroid impacted, some of the energy was transferred to the terrestrial rock, so not all the energy of the impact went into creating heat. Some of the energy went into the terrestrial rock and simply conserved the momentum of the asteroid, but sent the melted terrestrial rock heading towards space. The impact itself was probably fairly shallow, maybe in the range of 30 degrees or so. Probably wasn't very low impact, but it certainly wasn't high angle impact, as we can see from the distribution of tektites within the Australasian strewn field. The material was ejected probably in a sheet-like fashion as it got up through the atmosphere, and the atmosphere exponentially decreases as you go up by about 32 kilometers. I think about 99% of the atmosphere is below you. So the higher this sheet goes, the better it is for ejecting these tektites. This sheet gets disrupted and the tektites break into different shapes. The primary shapes, we call these, and the primary shapes are spherical bodies and dumbbells. And dumbbells here, these are created by, it's basically going like this. You get centrifugal forces sending it out. When these are spinning really, really fast, they break into two and you get teardrops like this. These ones are actually from the Philippines, but it doesn't matter because you get the same forms across the Australasian strewn field. Interestingly, the abundance of dumbbells to teardrops does vary from locality to locality. Teardrops are commonest in Indo-Chinese region. The reason for this is probably the initial melts are the ones, the first form melts are the ones, the tektites, which are ejected the furthest. So the Australasian tektites formed first, even though they probably landed last, they formed first. And most of them are originally spherical forms. Similarly, Philippinites, they formed slightly later on after Australites, but before Indo-Chinites. And they're mainly spherical forms as well. Then when you get to Indo-Chinites, they were the last formed tektites, and you get a lot of teardrops in this. Also, dumbbells are pretty common as well. So why do we get these forms? Why are these more prevalent in the Indo-Chinese region? Well, probably by that stage of the impact, the heat is being distributed over a larger amount of rock. So it's not being melted to such high temperature. If it's not being melted to such a high temperature, it's going to be more viscous. A more viscous melt will encourage formation of these shapes. Additionally, I think that these were maybe not ejected as high in the atmosphere. Maybe they never fully exited the Earth's atmosphere, and consequently I think the friction of being in the denser air it does tend to draw things out, to stretch things. Whereas, you know, if something's forming in space, it's a hell of a lot easier to form a sphere.